Good morning. So thanks for the introduction, Gael. Yeah, this morning the idea is to talk about some of the open source technologies that we have at Eclipse for building an open Internet of Things. So when I say the technology we have, it's actually the project and the open source project developed by all the members that are involved with the Eclipse Foundation and all the companies and all the individuals who work to provide the open building blocks for the Internet of Things, the protocols that we need for the Internet of Things, the security layers, the frameworks, the server-side technology, the home automation technology. And so today I want to basically give you an overview of all those projects that we have, why it's important to have open source technology at the heart of the Internet of Things. And I will probably start with like the regular chart with the future of IoT. There will be billions of devices by 2020, billions, trillions, whatever. I mean, IoT is big for sure, but something that is rarely mentioned when you hear in the news that IoT is going to be big is the fact that by 2020, according to a study by Vision Mobile, there will need to be 4.5 million developers trained to IoT, and there will be 4.5 million at least developers working on IoT technologies. And what is actually interesting is that those guys, those analysts, they did the same kind of study for when mobile was just beginning, right? When Android was basically just coming on the market and iOS and stuff, and they did the same kind of forecast, and they were wrong by one order of magnitude. So there will need to be lots of developers trained to IoT by 2020 and in the next decade. And what is important, and I will probably use this as an excuse today during the talk, is that there is actually lots of developers out there already, especially Java developers. And it turns out that at Eclipse IoT, we have lots of building blocks and a lot of open source technologies for Java developers. And I will use this again as an excuse to walk you through all the protocols that we have at Eclipse IoT and all the technology basically that we have for building end-to-end IoT solutions. And yeah, Java, I mean, there are 9-10 million Java developers. Java for embedded is kind of nice, right? I mean, I'm not here today to say that Java is the solution for IoT. Of course, on some very constrained devices and some very constrained microcontrollers, it's just not an option, but still there is good support for Java on the server side, good support on the gateways, good support on the embedded, good support on ARM-based devices. And tooling-wise, like in terms of IDE, there is Eclipse, but there are also other IDEs that are pretty nice for Java developers. And yeah, what if we could use Java for building end-to-end IoT solutions, or at least to have to help build and connect things. That's what we have at Eclipse. We have basically a whole ecosystem of open source projects that help you provide all the all the software you need for connecting your devices. So on top of the JVM, you would have all the services for building your gateway. Basically, you have sensors on the field that you want to at some point connect to the internet, right? You want to provide them with internet connectivity. So how do you do that? Well, you have some sort of gateway that will run Java plus additional services, and you will put some logic and some intelligence in the gateway. So for that, we have some embedded frameworks that we're going to talk about. We're talking about connecting things, right? So open source implementations of protocols that are important for the Internet of Things. We're going to talk about MQTT, about CoOp today, probably a bit about lightweight M2M as well. And once you have all those enablers, basically the protocols and the gateway stack for connecting and for managing your devices on the field, then you can start building what we call solution frameworks. Like if you're interested in home automation solutions, in industrial monitoring, you would have additional services on top of those enabling building blocks. And of course, I mean, we're talking Java, or we're talking, I mean, you need to develop solutions, so at some point you will have support in your Eclipse IDE, or in your IDE, you will have dedicated tooling support and stuff like that. Hello Didier, how you doing? So yeah, how does IoT work? Well, a very simplified vision or architecture of IoT is, as I said just earlier, you have those actuators and sensors on the field that you need to connect all the way to the end user that's going to need to interact with the data, interact with the devices. You want to control the devices, you want to access consolidated data, consolidating metrics coming from the sensors, so you will need to bridge them, connect them to the internet. The gateway is going to make sure that basically you have internet connectivity, and if your sensors on the field are connecting using maybe some sort of local wireless protocol, the gateway is going to use a 3G, a cellular modem, or a Wi-Fi connection to provide actual IP and internet connectivity. The gateway might also deal with the fact that the network will not always be on and will not always be reliable, so the gateway might do some local data consolidation. And yes, the gateway is going to bridge the sensors to the internet, so as you, as an end user, you can access the data. And there might very well be, at some point, some sort of server middleware, so as you, as an end user, it's kind of unlikely, or at least in most architectures, you don't really talk directly to your gateway, hence to your sensors and actuators, but there is some server-side middleware that's going to do the data consolidation, and that will basically be a broker between you and the sensors on the field. So yeah, connecting actuators, sensors, they will be using all kinds of, I mean, legacy technologies. Like if you're talking industrial monitoring, it might be Modbus. If you're talking about a car, it will be CAN bus, maybe stuff like that. And at some point, you want to build a gateway that will take data from those sensors and connect that to the internet. So what is a gateway? Well, if we're talking DIY sort of stuff, I mean, you want to prototype the Internet of Things in your garage, a Raspberry Pi is a gateway, right? There is, you have the ability to connect sensors to the GPIOs of the Raspberry Pi. You can talk to a temperature sensor over I2C. You can use maybe USB to connect via a USB dongle. You want to access a Zigbee network and whatnot. And you have internet connectivity, so you will basically bridge the world of sensors to the world of the internet. And this is on this device that you will run a dedicated software that is going to help you, provide you basically with an application framework to build the IoT application that's going to take the values from the sensors and send that to the internet. If you're talking more industrial kind of solutions, this is most likely what you're looking at when you want to connect a car, when you want to connect a factory to the internet. Then you want a device that's going to be able to deal with a very humid environment or very hot environments. And you want, something that's ruggedized and that provides lots of connectivity, probably even more than the Raspberry Pi, right? We have RS-232 connection. We have several Ethernet ports, more USB connections, etc., etc. And the idea is that this device, the gateway, this is what's going to help you. Again, in most architectures, you will use this gateway to connect the sensors on one end. You want to use this as an internet gateway that will allow you to translate the world of sensors to the world of the internet, and you will likely use some protocols that are appropriate for the Internet of Things. You want to make sure to be careful to not use too much bandwidth. You want to be reliable even on very constrained networks where maybe the packets are very small and stuff like that. And once you've tackled the issue of connecting the sensors, you want to do actually the tricky part, and the part that many people who build solutions in their garage forget about, managing the solution. You want, when you go production with your solution to connect cars or to connect a factory, it's not like you will be able to go on the field to deploy a new software. It's not like you will be able easily to go on the field to reboot the device if there is something wrong. You cannot really like unplug and replug the device like you would do if you're in your garage and you have the Raspberry Pi just next door, right? So that's the kind of basically features you would expect from a gateway, the ability to connect and to manage your solutions. For connecting, as I said, you need dedicated protocols. We're talking cellular, we're talking Wi-Fi, we're talking 6LoWPAN. You don't want to use, well, HTTP and SOAP, say. Like, you don't want to use XML to send IoT data. We're talking about sensors that are reporting data very regularly, like temperature data every minute over cellular. You don't want to use megabytes or gigabytes out of your data plan for just sending a very tiny integer that is your temperature, right? So you want to make sure that you are very efficient in terms of bandwidth consumption, and you want also protocols that allow you to easily do push sort of requests, right? You want to when you want to send a command to a device, you want a protocol that allows you to do push notifications, right? So there are two very popular protocols. These are not the only ones, but at the moment they are really getting lots of traction. One is CoOp. So who knows about CoOp? Wow, quite a lot actually, like half of the room. So CoOp is the Constrained Application Protocol. It's an IETF protocol. It's 5-ish years old. It's basically HTTP over UDP. The idea is that it replicates the REST model, you know, get, put, post over UDP. So instead of having HTTP headers that are like super large strings, these are instead binary headers, and it's really meant to have a very lightweight REST model on top of UDP. And it's very appropriate when we are talking about what is unfortunately not a reality just yet, but hopefully will be soon. That is an ideal world where every device in the world has an IP address. We're talking IPv6 all over the place, and then why not exposing the data from all the sensors by just having all the sensors behaving as little servers that you can query anytime you're interested in getting a value, or that you can talk to when you want to toggle a switch or stuff like that. So that's CoOp, and the other quite popular protocol is MQTT. It's a PubSub protocol. The idea is that devices on the field are all able to talk with each other by talking to a broker, and so they can send command to the broker that will dispatch the command to all the interested devices, and the other way around. If you're interested in receiving commands, you can subscribe to specific commands on the broker, and that's another quite popular protocol. So yeah, CoOp, essentially the idea is that all those things, my light bulb, my smartphone, my smart building, they are all resources in the Internet of Things. And whenever I want to know, say, the current status of my car's engine, then I just issue a GET request on the device. So at Eclipse, we want to provide the reference implementations of CoOp. And it turns out that for Java developers, there is a project called Eclipse Californium, which is the Java reference implementation of CoOp, and that provides basically all you need if you want to build CoOp-based solutions, including the security layer and including lots of code samples and lots of applications that you can use to get started if you're interested in, for example, providing a bridge between a CoOp network and the good old HTTP network. that's actually quite trivial because CoOp is basically modeled on HTTP, and you would have this kind of code directly available in Californium. MQTT, that's a model where the devices, they talk to a broker, and that the broker is acting as a sort of mediator between all the devices. So if I were to monitor the status of my kettle from my smartphone, I'm interested in getting notification whenever the temperature of the kettle changes. Then from my smartphone, I will run an MQTT client and talk to the broker, connect to the broker, subscribe to a specific topic. Topic are where and how all the messages are structured. So I'm interested in anything kettle 232, any message posted in this namespace, if you will, I'm interested in receiving it. So what's going to happen eventually is that another MQTT client is going to publish a message on the said topic, in which case it would be kettle 232 / temperature, and the message content will be the actual temperature, and then immediately the broker, knowing that this client is subscribed, will dispatch the notification, and that way you can have you can easily implement one-to-one, one-to-many sort of communications. At Eclipse, the reference implementations of MQTT, they live in the Eclipse PAHO project. So PAHO provides not only Java implementations of MQTT, but also JavaScript, .NET, C, C++, including C embedded. Like if you want to run MQTT on your microcontroller or on your Arduino, there is an implementation for that, Golang, Lua, etc., etc. And on the server side, if you want to run Mosquito on your server, basically it will provide you with an MQTT broker, an open source MQTT broker that is quite scalable. If you're interested in running a Java-based server, that would be Moquette. But that was kind of the easy part, right? Connecting. I mean, we're talking about getting data from a temperature sensor and then using a few lines of code for publishing the data to a server or for exposing the data as a CoOp resource. But that's again something that's quite easy to do if you've all played with Arduinos and the like. That's kind of the easy part, and building one solution, one application that will do this, it's quite easy. But what do you do when you want to go production, or when at least you want to have more than one device and one solution connected, and you start having several locations where you deploy your solution? How do you make sure that you can, once the solution is deployed, that you can upgrade the software that's running on the gateway, right? You want you're talking about a solution connected using a cellular modem. Well, at some point you want to upgrade the radio module of your cellular modem. These things happen. How do you upgrade the networking rules of your gateway? You're about to deploy a new application that requires a new port to be opened on your internet gateway. How do you do that? How do you deploy new applications? I mean, of course, I've started prototyping my solution where I connect my kettle, but at some point I want to do more than just monitoring the temperature. I want to have a more a smarter algorithm. I will deploy a new application package. How do I do that? How do I start or stop existing applications? How do I reboot my device? How do I provide a nice abstraction layer so as application developers can easily build applications without having to reinvent the wheel all the time? Like if when it comes to talking to a Modbus sensor, there must be ways for developers to not have to reinvent and to redevelop their Modbus stack all the time, right? So at Eclipse, technology that we have for building smart gateways and for providing an application framework, an application development framework right on the gateway is Eclipse Korra. So again, this is for Java developers, but essentially the idea is that on top of Java and OSGI, you have all the services to help you as an application developer, to help you not have to worry about the connectivity. As an application developer who wants to connect a kettle to the internet, I don't want to have to manage what happens when the network is down. How do I store the data locally while waiting for the network to be on again, and then I will flush the data and send the data to the server. I want the framework to take care of that for me. So that's what the kind of services that Korra would provide. As an application developer who wants to talk to a Bluetooth low energy sensor, I don't want to have to redevelop or to bring my own Bluetooth library. I want the framework to provide me with APIs to develop easily against Bluetooth, the Bluetooth APIs. So that's the kind of services that Korra would provide. And usually when I want to explain Korra, that's basically the same kind of software you would have on your DSL box at home. When you install Korra on the gateway, essentially it turns the gateway into a smart gateway that is not only an application container, but also a gateway that will provide you with all the nice GUI, the nice user interface to actually administer your GUI, like your gateway. Like if you want to deploy new applications, you just open a web browser and you install applications right on your device. You can also, of course, do that over the air. Like if you want to deploy applications on a fleet of devices, you can also do that using remote APIs. But out of the box, if you install Korra on your Raspberry Pi, and that would be exactly the only things you need to do to install Korra on your Raspberry Pi, you take on your Linux distro, you install the Korra application package, the Korra Debian package, and once you reboot your Raspberry Pi, you basically have the same kind of features you would have with, say, OpenWRT. You start having a nice GUI to administer your networking rules and control all the applications that eventually you will deploy on your Raspberry Pi, on your gateway. So the kind of features that Korra provides is what you would need typically from an IoT gateway. Everything network management, like if you have a 3G stick attached to your gateway or some sort of cellular modem, Korra can take care of establishing the PPP connection and make sure that you have internet connectivity over cellular. Same for Wi-Fi. If you want your gateway to provide NAT rules or to be a firewall between the edge of the network and the kind of local network you have behind the gateway, you can configure all that right from Korra without having to do like the native Linux stuff. You have a common abstraction layer on top of Linux. You have everything for managing your system and the OSGI and Java applications running in the device. And you have, and that's actually one of the most important features, you have an abstraction of the communication layer. To my point earlier, when you are an application developer interested in publishing temperature or sensor data to the internet, you don't want to manage the life cycle, the connection lifecycle. You want the gateway to connect once and for all to, say, an MQTT broker, and then you know that all the applications running on top of Korra, they will basically have an always available an MQTT communication channel. So the kind of APIs that are available as an application developer, without going into much details, would be, well, what you expect from an IoT application framework. You want to be able to do crypto, like if you want to publish data and cipher the data that you are exchanging between the devices or between the device and the cloud. You can do ciphering. If you want to have access to a GPS, you have an abstraction of a location service. And this is Java, so you can leverage the whole ecosystem of Java libraries that are available out there. Because what's important and what's important to have in mind is that we're talking about gateways. That is typically devices that are mains powered and that are not really constrained in that. I mean, we're talking about a PC basically. So the role of the gateway is basically to provide enough processing power so as the DEMB, usually non-IP capable sensors on the field, can actually be proxied and bridged to the internet via a quite smart and quite powerful gateway where you can run pretty complex applications that will do data consolidation, that will do anything you need to do before actually sending data to the internet. So a quick demo of what Korra looks in action. So I have a Raspberry Pi over here. Hopefully my internet connection will not die on me. And so this, as I said, in order to control my Korra runtime, I can actually open a web browser, and I have access to a nice user interface where I can manage and see what's happening on my gateway. So I can easily have access to the status of my maybe my Raspberry Pi is dead. It doesn't look like it's very much alive. Yes, it's dead. Great. Well, I've talked too much anyway, so I will probably move on. I should have a slide with like a nice joke about the fact that the demos always fail. Anytime during a break later on, if you want to see a Korra demo, I'd be happy to show you a demo of Korra in action. But essentially the idea is that it's really easy to install on your Raspberry Pi, and you have all the APIs to build your IoT applications. The application that I wanted to show you was basically using those very simple sensors. I have here a temperature sensor and an LED, and the application that I'm running on the Raspberry Pi is taking data from those sensors, publishing the data using MQTT, and the nice thing with MQTT is that it's really a super lightweight protocol, and there is a huge ecosystem of libraries and clients that are available, which means that consuming the data is really easy. If you're interested in visualizing the data in using Java in the JavaFX chart, then you take the MQTT Java client, and you can start plotting the data on the JavaFX chart. If you want to use a more advanced reporting technology, you can use Eclipse BERT. If you want to visualize your data in a mobile application, well, there is an iOS client and an iOS MQTT client, or you can use the Java client just as is in an Android application. You can do MQTT over WebSockets, which is also a nice if you want to build an application with no backend. Basically, in pure HTML and JavaScript, you can start visualizing your MQTT data. So that's also pretty nice. And maybe at the very end, I will be able to quickly show you the demo. So that's, I mean, again, that was sort of an excuse to walk you through some of the projects that we have for building IoT solutions, but that's certainly not the only thing. Of course, Korra is pretty nice, so go and download it. The demo that I wanted to show you, if you want to replicate or at least to understand better how it was done, there is a full tutorial that's available. Like it walks you all the way from buying the actual hardware to developing the application, running the application on your Raspberry Pi. So you can have a look as well. And Eclipse IoT is certainly not only Korra and MQTT and CoOp, and it's certainly not only Java. I mean, I've mentioned that Paho, for example, helps you if you're a Python developer or a Lua developer. This is actually the case for many other projects. Later today, there will be some presentations about Eclipse Smart Home, for example, which is also a nice project in the Eclipse IoT ecosystem for doing home automation. We have many projects, and actually, I wanted also to spend a few minutes to not only let you know that it's important that you get involved one way or the other. We are an open source community. All the projects that I've shown, they are developed, and the people who worked on those projects are either passionate individuals or companies that basically build commercial products on top of this. But if you use the technology and find bugs, please get in touch with the projects and open the bugs, ideally provide patches for the bugs. If you find some limitations to some of the libraries, to some of the projects, it's also important to give feedback to the project and possibly request new features. If at some point in your life you play with the technology and you think you have you've used the technology in an interesting or in a new way, I mean, you can always write articles and stuff and help promote the technology. By the way, if you do, please get in touch with me so as I can help possibly promote what you've done. The mailing list of all the projects that I've mentioned are usually pretty active, and if you have any question, you will get answers there. If you think you have open source projects that would be useful in the context of what I've shown today, we are also always welcoming new project proposals. That's also, I mean, we kind of like the idea of being the home for everything open source IoT. And maybe a few words about what's next for Eclipse IoT. I've talked about what's there today, but a few trends for IoT in general probably, but for Eclipse IoT as well. One very important topic is device management. I've mentioned a bit what is device management, like the kind of stuff you want to do when you want to upgrade the application running on your IoT gateway and stuff like that. There is a very interesting standard called Lightweight M2M from the Open Mobile Alliance. And this is typically the standard for doing device management and for having a standard way to monitor and control the applications running on an IoT device, to control the battery level, the cellular, the radio, the strength of the radio signal of a cellular modem. It's also a standard way to do firmware upgrade and stuff like that. So we have open source implementations of Lightweight M2M, both client and server, in C and in Java, which means that we basically have all you need for managing like super constrained devices, but also Java-based devices. And there are interesting discussions to provide implementations of Lightweight M2M over MQTT. The likes of Sierra Wireless, Bosch, SI, IBM are actually working now on providing Lightweight M2M over MQTT. In order to standardize the semantics, data semantics, and like units of measurements and stuff like that for IoT sensor data. There is also Ipsos Smart Objects, which is getting some traction, and we will hopefully have implementations at Eclipse IoT. If you are interested in learning more, please come and talk to me afterwards. I'd be happy to let you know what's currently happening. Security is going to be important in IoT. Lots of people talk about security in IoT. Very few people actually address the problem. They are more spreading fear, uncertainty, and doubt rather than actually addressing the issues. We are starting to get some interesting work done around security at Eclipse. TinyDTLS is an implementation of TLS and SSL basically for CoOp and UDP, and it's going to become an Eclipse project. And in terms of server, of course, we have the MQTT brokers. This is not really what I would call an IoT server and an IoT middleware. We need more services. We expect more services from an IoT server, right? Data consolidation, user management, security, of course. And yeah, there are interesting and ongoing discussions around what would be needed to provide an open source IoT server. And again, Bosch, TR Wireless, IBM are starting to work on this. And if you want to join the discussions, please come and talk to me. Again, I think we are headed to some interesting work in this area. So I think I'm probably starting to run out of time. I hope you have questions. If you have questions afterwards, feel free to drop me an email or to ping me on Twitter. Again, where you want to go if you want to learn more about the initiative is iot.eclipse.org. In the next couple of days, we will actually deploy a new version of the website that is going to be and look much nicer. But in the meantime, I mean, you already have all the information there. Or better, you ask your questions now. Thank you. Sorry, was it too technical for waking you guys up?
Olivier? Just an open question for the Eclipse community. It's really about, so we can see that you really target the C language and Java language. And now there is lots of projects also that use JavaScript, for example. Can you give us some idea why or how you plan to integrate such kind of project in Eclipse IoT global project?
Yeah, so we actually have some projects that do JavaScript, or at least, I don't know if your question is rather about JavaScript on embedded devices like Tessel and stuff like that, or JavaScript like Node or
like more like Node. So
yeah, so we have a project called Ponte and so that's a server-side technology. Ponte is a is technology for bridging HTTP to CoOp, CoOp to HTTP, MQTT to CoOp, and it's based on Node. I think there was some discussion also to have an MQTT broker implemented in Node that will come to Eclipse. Well, I mean, it's on GitHub right now; it's already open source. But unfortunately, I think, I mean, the hobbyist community is working on lots of Node-based server-side technology and nice. I mean, Node-RED is also a very nice tool, right? But the industry, the server built by the likes of IBM and Sierra and stuff, this is good old Java still. So yeah, I mean, I guess we will still see some contribution in the coming from the Node.js community. But yeah, maybe not as much as what we see for Java and C for the embedded side.
Okay, thanks.
Hi, thanks for the very interesting talk. You were mentioning Java even for embedded devices, and I know that some people are using Java quite successful on microcontrollers. But what would you see as a lower bound for Java on microcontrollers in terms of memory, in terms of energy consumption, in terms of latency?
In terms of energy consumption, I'm not sure I would have the answer. However, the most recent announcement from the likes of Oracle is that they typically run Java on this kind of guy, right? The embed. So that would be, I mean, we're talking about 100 Ks of flash, 32-ish Ks of RAM, and Cortex M3 sort of device, and they actually run Java on this kind of target. Again, I don't know in terms of energy consumption, but it's I mean, you can run the MQTT Java client or Java mobile client on this sort of device. Certainly not as efficient, I would assume, in terms of battery consumption as Riot, but yeah.
But do you know what kind of Java virtual machine they are using? Is this open source JVM or?
That wouldn't be open source, unfortunately. Nope. I don't think it is. I mean, Kai, do you know?
Java ME from Oracle, which is not
Yeah.
But
It's probably free of charge to some extent, but not really open source.
But is Java But is Java ME small enough for 32K of RAM?
Yeah, they have a profile that is
Okay.
It runs on the, I mean, not on this embed, but the Freedom board, right? The Freedom K64 or something. So it might be a bit beefier than this guy, but still we're talking maybe 64 Ks of RAM. But I can double check later.
Okay, thanks.
Thank you.
So, question? No. Thank you, Benjamin.
Thank you. Thanks.
So.